Okay, good day, student. This is me again, Sir Navarro, and welcome to our YouTube channel. So for today, we're going to discuss about the graphs of quadratic function. Alright, so before we proceed, you can get your notes or any papers so that you can write on scratch paper. To proceed, let's have a recall on the general form of the quadratic function. So this is y equal to ax squared plus bx plus c. So this is the quadratic term. Our linear term is this one, and then the constant term. So what is the linear term of y equal to 4x squared minus 3? So if you notice, there is no linear term, so that's 0x. What is the linear term for y equal to x squared minus 5x, so that's negative 5x. And this one, what is the constant term? So the constant is not there, so that's 0. Can the quadratic term be 0? So if this one is 0, can we still call it quadratic? So it's not anymore quadratic. Rather, it's a linear function or equation. So the answer is no. Right, so the graphs of quadratic functions. In this video, by the way, we're going to discuss the properties of the graphs of quadratic function and how to graph quadratic functions in two ways. Okay, so the graph of a quadratic function is what we call a parabola. Okay, so parabola, so it has a shape of this one, so it's a U shape. So a parabola can open up or down. So if you may recall the sign of McDonald's, if I double the green one, then that's the signage of McDonald's, or the symbol or the logo of McDonald's. So if the parabola opens up, the lowest point, this one here, if it opens upwards, the lowest point is what we call the minimum point, but this is also the vertex point. Okay. And if it opens down, the highest point is what we call the maximum point, and is this also a vertex? Okay, so vertex. So note, if a parabola opens left or right, it is not a function. Okay, so for it to be a function, it should open up or down. So the standard for this is not standard. General form of a quadratic function is general of a quadratic function is ax squared plus bx plus c. The parabola will open up when the a value is positive. Alright, so it's positive, a greater than 0. And it opens down if a is less than 0 or negative. So it faces down if a is negative. Faces up is if a is positive. So again, a must not be equal to 0 at all times. It's either negative or positive. Parabolas are symmetric. Okay, when you say symmetric, whatever the other side is reflected on the right side. Let's say on the left side, this one, so it will be reflected on the other side. If we draw a line in the middle of the parabola, we could fold the parabola in half, right? We call this line, this blue line, as axis of symmetry. If we graph one side of the parabola, we could reflect it over the axis of symmetry. So if we try to graph this side, then you're just going to reflect this side here using the points that you accumulated from this side, and then you connect it using a smooth curve. So we could reflect it over the axis of symmetry to graph the other side. So again, axis of symmetry, this one. So if we're going to graph the right side, then you're just going to reflect these points that you've made on the right side to the left side. So that one. The axis of symmetry always passes through the vertex. So diba, this is the vertex. So if you notice the axis of symmetry, it passes through the vertex. This one. So let's have an example. This is the graph of y equals, or f of x equal to x squared, and this is the graph for the y equal to negative x squared. So if you notice, the graph of y equal to x squared is 1, opens upward, while y equal to negative x squared opens downward, because in this one here, a is positive and this one is a is negative. The vertex of y equal to x squared, this one here, is 0, 0, also denoted by v 0, 0 or vertex 0, 0, which is the lowest or minimum point on the graph. It is the minimum point if the parabola opens upward, just like what I said earlier. The vertex of the other graph, this one, is the function y equal to negative x squared is also v 0, 0. But it is the highest or the maximum point on the graph, right? So when you say highest, let's say you're in the mountain, usually, or you're on the top, right? Same goes here. So if this is if the point is on the top, then that means it's the highest point, right? On the other end, the other graph, if it faces upward, like there's a slope, and then when you reach the end of the slope there, from a mountain, but that is the lowest point in that perspective, right? So that's the lowest or minimum point. So the minimum point or the maximum point serves as your vertex also, or your turning point. So the vertex is the vertex is located where the turning point is. So the turning point, literally, it is where the curve goes on. Okay, so drawing a line through the vertices of each graph divide both graphs into two congruent symmetrical parts, such as one part is a mirror image of the other. We call this line the axis of symmetry. Thus, the axis of symmetry, both graphs, is the y axis, or the line x0. So given in the example that I gave you, but this is y equal to this is y equal to negative y equal to x squared. So the axis of symmetry here in the first graph is x equal to 0, because this is the y-axis. Sometimes we call it x equal to 0 or the y-axis. The same goes here, but there are times that the graph does not go here. So we'll have an example later. So this is our axis of symmetry, and then this is our vertex. So when a quadratic function is in standard form, the axis of symmetry, remember the standard form or the vertex form? So this is the general form. So to get the axis of symmetry, you can just actually use this one. X equal to negative b over 2a. The opposite of b, or the negative of b, divided by 2 times a inwards. So find the axis of symmetry for y equal to 3x squared minus 18x plus 7. So a is, you have to identify the b and a, or the a and b. So a here is positive 3 and b is negative 18. So you try to get it. Okay, so if you solve it, the axis of symmetry is, symmetry is negative or positive. It's positive, again, positive 3, alright? Am I correct? 3. So we'll have another example later. So the axis of symmetry always goes through the vertex. Thus, the axis of symmetry gives us the x coordinate of the vertex. So this means that if you have the coordinate of the vertex, then you're just going to use the x coordinate of it, and it will serve as your axis of symmetry. So first you have to find the vertex. So to get the vertex, you solve for this one. Find the axis of symmetry. So the other way of finding the vertex, aside from transforming it to the vertex form, is to use the formula, remember? So first is you have to find the axis of symmetry, which is x equal to negative b over 2a, using this function. So a is equal to negative 2, b is equal to 8. So you substitute it there. Excuse me. Okay, so negative b over 2a, and then substitute negative 8 over 2 times negative 2. That's basically negative 8 over negative 4, or positive 2. So to get the y coordinate or y element, diba, we already have the x or the axis of symmetry. How do we get the y? So to get the y, simply substitute this x here in the equation, in the function. So 2 square plus 8 times 2. Then that becomes negative 2. 2 squared is 4. So negative 2 times 4. Then 8 times 2 is 16 minus 3. Then negative 2 times 4 is negative 8 plus 16 minus 3. Basically, that's 5. So meaning to say, the vertex is 2, 5. Okay? And your axis of symmetry is x equal to 2. Okay, let's have here. This is the first way on how to graph quadratic functions. So the other one maybe we'll have it on another video. So one way of graphing quadratic function is, the function by the way is y equal to x squared plus 2. So one way of graphing it is this one, using tabular or the points ordered pair. Okay, so let's say if the function is y equal to x squared plus 2, so then you have this random values of x. Okay, so it doesn't necessarily need to be consecutive, but I use the consecutive values now. So in this case, we have negative 2, negative 1, 0, 1, 2, 3. So how do we get the y? So to get the y, you just simply substitute it here, the x values. So for example, negative 2. Negative 2 squared is 4, plus 2, that's 6. Next, negative 1 squared, that's 1, plus 2, that's 3. 0 squared plus 2, that's 2. 1 squared plus 2, 1 squared is 1, plus 2, that's 3. 2 squared, 4, plus 2, that's 6. 3 squared, that's 9, plus 2, 11. So let's connect now the ordered pairs. We have negative 2, 6. Where is it? Negative 2, 6. It's somewhere negative 2, then 6. So it's here. Negative 1, 3. So negative 1, 3. It's here. 0, 2. It's here. 1, positive 3. Here. 2, 6. Then 3, 11. Alright? So I hope you follow. Now, how do we connect that? How do we graph that? So we can connect it using a smooth curve, remember? So you can just actually draw a line, not a straight line between the points, but a smooth curve, no? Just like when you sketch a drawing, or when you draw. Okay? So use what's that? Smooth curve. So I cannot really write it here, but yeah, I prepared a part of the presentation. So anyways, you can just actually draw a smooth curve connecting the dots. It's like this. A smooth curve. So this is an ending process. So that means that it must have an arrowhead. Right? So that's one way of graphing the function.